Okay, so hello everyone, this video is going to be on C++ disaster second episode, and let's just get in. I would explain the context of problem. This is going to be a very short video, so let's just do it. Okay, so let's just have disaster.cc in here and let's start. You'd get the context of problem. So let me include some headers. So one is vector, and let us do some sort of printf debugging. So we have IO stream. Let me pollute my namespace with some, let's say, std. Okay, so let me pollute it. You should never do it. It's not a good practice, but because we are doing something, so we can. Okay, it's not a production application. Okay, and let's just have the main function in here and let's start it. Okay, so I would take a vector of integer, that is like vec, and then what we can do is we can start. We would start with a function. We would start with a function. So let's say I have a function that just takes an integer and it takes a parameter named index and returns the index itself. That is like the function operates over the index and returns something. So this function is something like y equal to x, something like that. And we have a loop for int I is equal to 0, I is less than let's say 1000, and then I plus plus, that is like classical for loop. And then what I would do, I would just push into a vector. So vec dot pushback I, and we would not directly push the index itself. We can push the function itself just to simulate that we are doing something with the index, just to simulate it. Okay, you can put anything in the function, it doesn't matter in here. Now if you are in the competitive programming field, you may or may not relate it, but what it is that when we have some sort of special index, let's say we have a special index like 6, we want to store it. Okay, so we have a special index based on some condition or something like that. Okay, so what we can do, we can have a vector of int iterator. Okay, so we can just have an iterator named itr. Then what we can do is, if itr is equal to 6, so sorry, if I equal to 6, then we can just have the that ith index iterator. So how we can take it is vec dot begin plus 6. Okay, so or maybe I. Okay, so that's it. You can do something like that, and you what you did is you stored that thing. Okay, so on the 6th index we have the I can say storage of integer, that is like 6, and let's just print it out, and it should work well according to me, or maybe not. Let's just see. So for a timing, I would just print out in here itself. Okay, oh my god, yeah. Let me just compile it. Let me just run it. Okay, so we got 6 in here. That's good. That's exactly good. Now what we should do is we should get out of here and we can print it outside of the for loop. Let's just see what just happens. And we are getting 6. There is no problem in there. So that's all fine. That's totally fine. Now let me just do the simple thing. So in here we have itr value, that is like vec.begin plus I, and I6 in here. So what we can do is we can just print out vec.begin plus 6 itself. Okay, and as expected it would print 6. That is fine, that's totally fine. So we are getting the result that is totally expected. Now let's just do some sort of disasters. Not here, we have already done the disaster, so let's just see it. What happens if we do something like star itr equal to 9? Okay, so because itr and vec.begin plus 6 both are pointing to the same place, that means we should print 9 2 times, something like that. So in here, okay, we should print 9 2 times now. Okay, so let us do it. Let us do it. Oh my god, what it's doing is it's printing 9 first time but 6 second time. Why it's so? Because what it does, it prints star itr for the first time and we c.begin plus 6 for the second time. And what is the difference in there? Because if we see the statements in here, both point to the same thing, and according to us it should work the same, like if I change one, the second should be changed, and that is what we are expecting. But no, it's not the same, it's not that thing. Okay, so here the guidelines of C++ comes into the picture. So what is there? What you can see is we have the iterator, and we have stored the iterator while pushing to the vector. So that means at ith index we just stored the iterator, that this is the iterator I want to have, that we occasionally do, and then we push the vector, and we just continued. Okay, so that was so great to have. But this is what the disastrous part is in here, because we should not do so. What is happening in here, that as we push more and more things for vector, the vector is dynamic array, and that means it is reallocating itself onto some other memory location. That means that this memory location is different from the other one. So that means after pushing 1000 elements, if the reallocation happens, then this itr and this vec.begin plus 6 both point to different memory locations. So that's why this thing is not working, and that's why actually the reallocation happens with taking 1000 members. I just made sure that reallocation would happen, and then we show that okay, this type of things happen, and this is where the bad things start to happen, because once we have written to the wrong memory location that was actually unallocated by vector internally, this is the undefined behavior. Okay, so it's undefined behavior, and if we are doing something undefined, our whole program behavior is gonna be undefined. So it may produce segmentation fault, it may produce anything else. So it's just a coincidence that it's working for the time being. Okay, so maybe if I just change it to let's say 2000, something like that, then maybe we would see something else. So let us do it, let us check it out. Okay, we are not getting, but of course it just happens. Okay, so this is the first thing in there. Okay, so we got the first thing, and let us start now how we can just fix it out, and let's just go with again C++ guidelines. So what the guidelines say, that if you want your program behavior to be more defined, and if you want to do something like this, then you should reserve the vector space. Okay, so what I mean is you should use this reserve function reserve memory function of the vector, that we will give something like, let's say we are pushing 2000 elements, so we will reserve 2000 elements. That means for 2000 elements there would be no reallocation. Okay, so if you after this point, if you will push more 2000 elements, there will be no reallocation. Okay, that means we have allocated space for 2000 elements that is there. So if you want to make your vector more and more predictable, so you should do vector.reserve. Make sure you are not using vector.reserve for doing some sort of optimization, that okay, I want to optimize my program, so I should reserve the space. This is not there. This you should not do so. You can maybe disturb the program if you are doing with the mindset of optimization. You can disturb the optimization techniques that is used internally, so you should not do so. If you want to have this defined behavior, well-defined behavior, you can go with vector.reserve. That is the first thing. The second thing is, once you push to the vector, or once you erase from the vector, okay, so it doesn't matter what you do, you should if you are not using reserve, okay, and the space is not reserved, then you should not rely that reallocation would have happened or not. Okay, so that is the undefined behavior. The undefined behavior here is after, if you don't have this reserved thing. Okay, so you don't have this reserved thing, you just push back something, and then you take the iterator and again you push back. At that time, that iterator value is undefined. Okay, and that means your pure program behavior is undefined. So now let's just try our program with vector.reserve. So let us try it out. Okay, we have in here, and we have the 9 and 9. That is the thing we wanted to have. So that is there. This is what it is. The second program for the C++ disasters. I think you should take care of it. You can read the guidelines for the vector iterators. Okay, that is like good thing you should always do. If you are working with C++, you should read the guidelines that is there. I hope you learned something. I hope it was helpful. One more thing. I was trying NewVim LSP today. So I was trying NewVim built-in language server protocol thing, and yeah, for the first time it went horrible. I will try it one more time, but in some days, okay, in 2 or 3 days, I'm gonna push that video on YouTube, so that if I were to make that happen, if I were to make that working, then yes, we will get the NeoVim LSP video on our channel. Okay, so okay, that's all about this video. Hope you learned some things. See you guys next time. Okay, yeah.